Our last homework problem gives us another little twist. It's asking the same questions, what's the rate law, giving initial rate data, but this time we come up with an issue that there is never, if you look at these, there's never a value of this compound, which is called peroxy disulfate, but there's never a situation where this stays the same. So I'll never be able to make this one vanish from my comparison. There is one example, one set of experiments where the concentration of iodide stays the same, and that's our key to success. Right? So, first of all, we don't have convenient doublings, so don't try to do this verbally. Mathematical is the right approach. And this one here, where the iodide changes, is going to be our important one. So we're going to start with finding the rate order for S2O82 minus, which again is peroxy disulfate. So using experiments 1 and 2, putting 2 on top because that's going to give me a positive number, I end up with these rate laws, and conveniently my iodide concentration cancels out. So I'm left with my ratio of rates equals 0.027 over 0.081 to the x power, or 1.5 equals 1.5 to the x power. Okay, so this one works out just fine. X equals 1 and the reaction is first order for S2O82 minus. Now, in order to use that effectively, I go to any 2 experiments and I put in the fact that I know it's first order. So if I use experiments 3 and 1, instead of putting an X, I can put in the 1 that I know is the rate order for peroxy disulfate. So now, the only thing that's going to cancel out is the K. But when I solve it, when you have a product, and basically when you have a common multiple, when you can bring something out of a fraction, you can separate it like this. So I can separate out this fraction from this fraction. And you can check this for yourself to see that this works all the time. So that means that my ratio of rates, which is 3.0, equals my ratio of the S2O8, which turns out to be 2, times 1.5 to the y power. Or 1.5 equals 1.5 to the y power. So y equals 1, and the reaction is first order for iodide. So the rate law is K equals concentration of peroxy disulfate times the concentration of iodide. Both of them are first order. So what's the average value of the rate constant? Well, again, I just have to take them all in, and I'll show them all to you right here. They're the same. I just substitute in for each experiment the rate and the concentrations. Rearrange it algebraically to solve for K, and I find out again and again that I end up with the same number with only a little difference in the last one for the rate. The units for the rate law, molarity to the -1, seconds to the -1, are because this is a second order overall reaction. So the average turns out to be, with rounding, 4.0 times 10 to the minus 3, molarity to the minus 1, seconds to the minus 1. Now, how's the rate of disappearance of S2O8 related to the rate of disappearance of I minus? Now, it's important that you pay attention because it says, I'll scroll back, it said at the beginning that these data were collected about the rate of disappearance of S2O8 2 minus. So these initial rate measurements are the rate of disappearance of this. Because every time we answer one of these, how do they compare? How does the rate of disappearance of one relate to the disappearance of another? We have to go back to the chemical equation. And the chemical equation tells us that for every one peroxydisulfate that disappears, three iodides disappear. You can also say that for every one of these that disappear, two of these show up, two sulfate ions, and one of those show up. But we're being asked about just these two right here. So, using the coefficients, we can tell that the iodide disappears 3 times faster than the S2O8 2 minus disappears, and algebraically, we could show it this way. They're both negative because they are both reactants and they are disappearing. So if you use the word disappearing, you can leave off the negative signs, as long as we can see that the connection between the two is that the iodide is 3 times faster than the peroxysulfate, disulfate. So then using that information, we find out what's the rate of disappearance of the iodide when the peroxydisulfate starts off with 0.075 molar concentration, and the iodide starts off with 0.050 molar concentration. Well, we use our rate law. If I substitute in my concentrations, they're both first order, so there's no exponents that I need to show. And when I solve this, I get 1.5 times 10 to the minus 5, and I know, because I read the beginning paragraph, that this is the rate of disappearance of S2O8 2 minus. Using the balanced chemical equation that from C, we know that this is disappearing 3 times this rate, so I just have to multiply it times 3, and this gives me 4.5 times 10 to the minus 5 molarity per second is how fast the iodide is disappearing. So if you can do all of these, you are ready for the quiz.